This video is for class 9 physics, and today we are starting heat and energy, right? So according to the reduced syllabus, we have this part, we have this part, and we have the last part, which is the greenhouse effect and global warming. Here, this part. So let us begin the chapter with the first topic, heat and temperature and anomalous expansion. So beginning with the concept of heat energy, here in this paragraph we will try to understand that heat is a form of energy, right, by our common experiences, right. In our common experience, that on rubbing our palms, they get heated. On passing electric current in a metallic wire, the wire gets heated. On burning a coal, we get heat. On pumping air in the bicycle tube, the barrel of the pump gets heated. In all these cases, heat is produced either by doing some work or by providing energy in some form or the other than heat. On rubbing palms and on pumping air in a bicycle tube, heat is produced by doing work, that is from mechanical energy. While on passing current in a metallic wire, heat is obtained from electrical energy, and on burning coal, heat is obtained from chemical energy. Thus, heat is a form of energy because energy can be produced from another form of energy. So heat is a form of energy. Remember that it is a form of energy. We have studied this in class 7 also. Now further going through that concept of heat, right, each body is made up of molecules. The molecules are in random motion, right? The molecules are in random motion, hence they will have kinetic energy, and each molecule exert a force of attraction on the other molecules. Because of this, it will have potential energy. Because of this, it will have kinetic energy, right? So because of this kinetic energy of the molecules and the potential energy of the molecules, we feel this energy as heat energy, right? Thus molecules possesses some energy, right, and the heat energy of the body is the internal energy. Here the internal energy is the sum of the, here it is written here, it is the sum of the internal kinetic energy because of the random motion and the potential energy of the molecules, right, due to the molecular attractive forces because of the force of attraction, right. I hope you understood this particular paragraph here, right. Let us go to the next column. Thus we saw that a hot body has more internal energy because obviously it will have more kinetic energy, internal kinetic energy, right. So when a hot body is kept in contact with a cold body, the cold body warms up and the hot body becomes cold. So here we are trying to understand the flow of heat. The internal energy of the cold body increases and the internal energy of the hot body will decrease. Thus energy is transferred from a hot body to the cold body when they are placed in contact. When they are placed in contact, the heat will flow. The energy which flows from a hot body to the cold body is called the heat energy or simply heat, right. So on touching a body appears hot to us when heat energy flows from that body to our hand, and while it appears cool to us when heat energy flows from our hand to the body. So the feeling, the sensation of the hotness and coldness is because of the flow of heat, is because of the flow of heat, right. So we feel hot when the heat energy flows from the body to our hand, and we feel cool when the heat energy flows from our hand to the body. When we lose heat energy, we feel cool, and when we gain heat energy, we feel hot. For example, if we touch a warm water, we feel hot because heat energy from the warm water passes to our hand. Similarly, if we touch a cube of ice, we feel cool because heat energy from our hand passes to the cube. Thus we can define heat as follows. Heat is the internal energy of the molecules constituting the body, right? It is the internal energy. Remember, this internal energy means the sum of the potential energy and the kinetic energy of the molecules constituting the body. It flows from a hot body to a cool body. So the coldest substance in this universe will also have some amount of heat because it is made up of molecules. As long as the molecules are there, there should be some amount of heat energy, right? So it's not only that hot objects will be having heat energy, even the cold objects will have heat energy, but it will have less heat energy, right? So let us go to the next topic, which is the unit of heat. So coming to the next topic, which is the unit of heat, right? So as you all know now, heat is energy. Sorry, heat is energy. Now energy has the unit which is joule, right? Therefore the SI unit of heat is joule and the CGS unit is org, and the relationship between the SI unit and the CGS unit is 1 joule equals to 10 to the power 7 org. Other units of heat are calorie, which is generally used, and kilocalorie, where 1 kilocalorie is equals to 1000 calories, right? And the units of calorie and joule are also related here. 1 calorie is equal to nearly 4.2 joules. Okay, 1 calorie is equal to nearly 4.2 joules. It's not necessary to remember this, but this is the number which we need afterwards also during our calculation. So this was the concept of heat. Now we are doing the concept of temperature. So when a hot body is kept in contact with the cold body, now we all know that heat flows. It is noticed that after some time the hot body becomes less hot and the cold body becomes less cold. Obviously this is because the flow of the heat from the hot body to the cold body, right? The body which imparts heat is said to be at a higher temperature. Now who decides the whether the body is the hot body or whether the body is the cold body? It is the factor temperature, right? So the body which imparts heat is said to be at a higher temperature than the body which receives heat. Thus temperature determines the direction of flow of heat. Right? So I hope you understood what temperature is now. So temperature is a factor which determines the flow of heat. When a body receives heat energy, the particles constituting the body starts vibrating with more energy, right? Vigorously, and its temperature rises provided its physical state or the dimension remains unchanged. So remember one thing here which you have studied which you have studied in class 7 also, which you will study in class 10 also. Temperature rises or falls provided the physical state, that is the solid state, liquid state and the gaseous state, does not change or the expansion does not occur, right? The dimension remain unchanged. That means no expansion also, right? So it's only that temperature is changing. Thus temperature is defined as below. Temperature is a quantity which tells the thermal state of a body, that is the degree of hotness and coldness of a body. It determines the thermal state of the body, that is the degree of hotness and coldness of a body. It determines the direction of flow of heat when two bodies at different temperatures are placed in contact, right? So I hope you have understood the definition of temperature also. Let us try to understand more about temperature. So if there is no transfer of heat between two bodies placed in contact, they are said to be at the same temperature, but it does not mean that they have equal amount of heat energy in them, right? This is very important. Okay, if they have same temperature does not mean that they have same amount of heat, right? Does not mean same amount of heat, right? In fact, temperature alone does not tell us the quantity of heat energy contained in a body. We shall discuss this in class 10 also. Experimentally, we find that by imparting some quantity of heat energy to different bodies, they get heated at different temperatures. For example, if we take copper and iron, okay, suppose you are giving heat energy, equal amount of heat energy to both these materials, the rise in temperature will be different because the materials are different. The amount of heat energy contained by a body depends on its mass, temperature and the material of the body. So three factors decide the amount of heat, right? So they are mass, temperature and the material of the body. These are the three factors which determines the amount of heat, right? Mass, temperature and the material of the body. In our common experience, suppose you take water and you take iron, obviously the iron gets heated up faster compared to water, if provided they are of equal mass. Okay, a unit of temperature, the SI unit of temperature is Kelvin, the symbol is K, which you all know, which you done in class 7 also. The other most commonly used, okay, unit of temperature is Celsius or degree centigrade and degree Fahrenheit. Okay, yeah, the temperature on the Celsius scale and the Kelvin scale are related as T Kelvin will be equal to 273 plus T degree Celsius. Okay, this is how you convert degree Celsius into Kelvin. Suppose we have 20 degrees Celsius, right? So if I add 273 to it, thus I'll get 293 Kelvin. Okay, thus by adding 273 to a temperature in the degree Celsius, it can be converted into the Kelvin scale. We don't use degree for Kelvin, remember. Actually, a degree on both the Kelvin and the Celsius scale is equal. This thing also we have studied in class 7. Okay, the ice point 0 degree Celsius on Kelvin is 273 Kelvin and the steam point 100 degree Celsius on the Kelvin scale is 373. Thus each degree rise in degree Celsius or each degree rise in Kelvin scale are same, right? The temperature on the Celsius and the Fahrenheit scale are related by this formula here. Okay, this formula can be used to convert the Celsius scale into Fahrenheit or Fahrenheit into Celsius. Here C denotes the value in the Celsius scale and F denotes the value in the Fahrenheit scale. The ice point 0 degree Celsius is 32 degree Fahrenheit and the steam point 100 degree Celsius is 212 degree Fahrenheit, whereas this Fahrenheit has different number of divisions than the Celsius scale, right? Thus 1 degree on the Celsius scale is 9/5 degree on the Fahrenheit scale, right? So these are the few things which we have discussed again actually, right? We have already discussed this in class 7, we are just revising them. Okay, so now we can go to the next topic, which is the difference between temperature and heat. So coming to the last point for this video, the last topic for this video is the difference between the heat and temperature, the difference between the heat and temperature, right? You can see point number 1, heat is a form of energy obtained due to the random motion of molecules and provided there is a force between the molecules also, that is internal energy, right? Temperature is a quantity which determines the direction of flow of heat on keeping the two bodies at different temperatures in contact. So generally this first difference is their definition, which you have discussed. Number 2, the SI unit of heat is joule, whereas the SI unit of temperature is Kelvin, right? This was also discussed. Point number 3, the amount of heat contained in a body depends on mass, temperature and the material of the body. So these were the three factors which determines the amount of heat. We have to do this in detail in class 10. Number 3, the temperature of the body depends on the average kinetic energy of its molecules due to their random motion, right? So rise in temperature or the fall in temperature only depends upon the kinetic energy, not on the potential energy. Okay, next difference, number 4, heat is measured by the principle of calorimetry. This principle of calorimetry also needs to be discussed in class 10, right? Number 4, temperature is measured by a thermometer or device, right? So here we are using a calorimeter and the principle also, right? Here we are simply using a thermometer, which is also a device. Here we are using actually the expansion of liquids. The principle used is the expansion of liquids. Number 5, two bodies having same quantity of heat may differ in their temperature. That means if two bodies have same quantity of heat, for example iron and copper are having 120 joules, suppose they are having 120 joules, right, but their temperatures might be different. Okay, the temperatures might be different, and two bodies have same temperature may differ in the quantity of heat contained in them, because the materials are different, okay. So iron and copper might be at same temperature, that is 40 degrees Celsius, but the heat content might be different. For example, suppose when you are watching the video, the heat contained, okay, of the substances in front of you might be different because the materials are different. Okay. Number 6, when two bodies are placed in contact, the total amount of heat is equal to the sum of the heat of the individual bodies. So when two bodies are placed in contact, the total amount of heat is equal to the sum of the heat of the individual bodies. For example, there is one body, okay, who is having 10 joules. I am keeping it in contact with the another body, right? I am making a blue in color, right? Suppose it has 20 joules. Now the total heat contained by the whole body should be equal to 30 joules, sorry. So it can be easily added. But when two bodies at different temperatures are placed in contact, the resultant temperature is the temperature in between these two bodies. For example, suppose you have a glass of water whose temperature is suppose 10 degrees Celsius, and suppose you have another glass of water whose temperature is suppose 50 degrees Celsius, right? So suppose you pour both the waters in a container, right, in a container, such that they are mixed now, they are mixed well, okay, such that they mix well, okay. So will the temperature be 60 degree? Obviously not, right? Obviously not, it's not possible, right? So therefore the temperature will be in between them, the temperature will be in between them. No, we cannot add temperature this way, otherwise it will be very simple, right? If you want to boil water, you just take 10 glasses of water, each glass will have 10 degrees Celsius, mix them in a container, hence the water will boil at 100 degrees Celsius, but it will not happen so, right? So this much for this video. I hope you have understood. If you have any questions, you can ask me during the Google Meet. Thank you so much.